Hello friends. One of the main challenges for a marketer is to predict churn right before it happens. So in this lesson, today I'll be teaching you how to predict churn using supervised machine learning models like KNN classifier. So let's begin. So we are inside this Jupyter notebook to predict churn, and right now the model that we'll be using is KNN, which is K nearest neighbors model, and you'll be learning about basics of how do we apply machine learning to marketing. So first of all, we'll be importing NumPy as NP. Second, we'll be importing the other module, which is pandas as PD, and then we have so the name of this data set is called telecom. It's sitting under pd.read csv, and it's under users, and in users it is specifically under admin desktop telco. So imagine this to be a data set for a telecom provider which has some data on customers and also knows which customers have churned in the past and which have not. So now we'll be using that we'll be using that data instead to make a model out of it. The second argument here is NA values, which are some values which are blank will be replaced by NA string values, and this is specifically in total charges column in this data set. And next up, now we have this should load this. Okay, now telecom is null dot sum. This should sorry, here. So here you can see total charges. Here you have null columns. So these were blank columns here, which have been replaced by any. And so let me also give you some information on the telecom data set. So here you can see all these are object data types except for senior citizen and tenure and monthly charges and total charges. So we'll resolve it soon. We'll convert it into dummy variables to be able to convert the string values into dummies basically. So next up we'll have to fill in the NA values with something basically. So telecom is equal to telecom.fill NA, and what do we want to fill it with? It's 0. And now telecom is null. If I look at it again, it's all 0, so no null values now. Okay, so next up we'll be using it. So we'll be dropping the customer ID, this first column that you see, because this is like a random generated ID which is associated with every customer. There's no need to include that as part of the model. So telecom.drop, then we have customer ID, and yeah, sorry, what am I writing here? This will be around axis is equal to 1. Okay, so next up we have telecom.head to understand how the data feels like and looks like. So there was a customer ID column which we removed, so now we have these basically columns and their values on the first 5 rows. So now we would make a variable called column, and we would store all the column names which which don't need to be converted into a binary sort of a value. So what we are right now here doing is that all the columns like gender, partner, dependents, we are converting into dummy variables, which is going to be values for 0 and 1. And the reason we are doing it is because we for the numbers for the values which are for the columns rather, which has some values, numerical values, we will leave it as it is, because we'll be using that as part of the model, and we'll be normalizing it, but we'll be using it like this only. But it is always better to convert your categorical variables into dummy variables, and that is what we're doing now. So columns drop. So I would not really want to here. So we have tenure, then we would have senior citizen, then we would have monthly charges, then total charges. These are the basically columns. Okay, sorry, I missed the list. All these have to go as part of a list, and yeah. So now I'll call it telecom new, and telecom new would ideally be like a database with dummy variables, get dummies, and passing in the database, and then the columns column, which is a reference value on for these columns. I mean everything except these columns basically. And then raw first is equal to true. This would basically do one thing, which is it will so for female it'll be, let's say 0, for male it'll be 1. So I'll just show you basically what it does. Hold on, there's a problem here. It feels we have get dummies, telecom column drop first is equal to true. Okay, sorry, this was supposed to be like this. So if you now look at telecom new, so gender male 0, this means that ideally if I hadn't dropped the first column, this would make gender male and gender female two different columns, and female would be 1 and male would be 0. So if whenever male is 0, automatically female becomes 1 and vice versa, so we don't need both the variables or columns there, so we've dropped the first one. That is what drop first do. Now we'll be using telecom new head. I've already shown you this, so I'll be grouping it group by so basically there's a column called churn yes, and basically I'm trying to now assess how important or what is the distribution like of churn yes values, which is zeros and ones, when it comes to the total database. This is just to understand how the split happening, and if there are only churn yes are all zeros, that means all the people have not churned. So that doesn't give a lot of information to our model to be able to learn it from the database. So that is just a hygiene check there. So what I'm doing here now would be to count and telecom shape. So you can see 73% of the people across categories have churn value for yes as 0, which is they have not churned, and 26% have churned. this is a good data set to work on. That means so. Next up, we will divide this into target variable, which is telecom new churn yes. So, and there is a variable column which telecom, basically everything you drop the first churn yes here. Okay, so if I have a look at variable.head, it has all the columns except for churn, and target has only churn. So this is just dividing the database into the independent and the dependent variables. I hope this is up till now very clear. Now this is the step where we will actually be using the model, in the sense that we'll be starting to develop the model basically, which is model selection. Sorry, selection, train, test, split, and the next one is we would basically, here you would see that X is in capital while I'm writing Y in small. This is generally used terminology in nomenclature rather, so no need to worry there. Train test split, I would divide my variable target, then we would have test size. I'm taking the test size to be about 30% of the total database. You could do something else, and just so that you also get the same thing, I'm using a random state, which is just a random number here, 42. You could write anything, but if you write the same 42 number, this would give you the same results ideally. So now moving on to the new modules that we would want to, the next one is the k nearest neighbor. From neighbor, import k neighbors classifier. Okay, next up we have, so we will be importing the grid search CV. So for people who don't know about what grid search CV is, basically here we'll be using different values for n neighbors to understand where the model performs the best, and for that we have a grid of all the n neighbor values, possible values in a grid, and which is where we use grid search CV, and we'll be using KNN and call the k neighbors classifier on it, and define the parameters as n neighbor So here I am taking a value from 1 till 100. You could take, you could settle for 50. That we will see later in the video that even lower value would do in this case. But I'm just taking a larger value to make a point, to make you understand that this could run for as many values as you would want. So next up, we'll be initiating KNN classifier to initiate grid search CV, and here we'll be using KNN model using the parameters that we have defined, and post that we'll be using a tenfold cross validation. So here we have the classifier build. We'll be fitting the classifier. So KNN classifier would be fitted on X train and Y train. And next up, once this is fit, I would, so this would, as you might be seeing that this is taking some time, this would take some time depending on the processor. And once this is, you have this classifier, this should give you the best scores. And I'm waiting for this to get over, and we should have this post that. I am also going to print the classifier best parameters. Params. Lastly, so here I also wanted to share one thing, which is we could right now, so here it says that the best parameter for the value for n neighbors is 29 and the best score is 0.77 or 78 rather. But we will slowly see how, this is 29, but I would also want to understand like what were the values for the score for different n neighbors to understand if whatever the value that we've set till 100, does it make sense or not? So going by that logic, what we would do here is we would call a print KNN classifier and call what is known as CV results. Okay, so what this would do is this would print all of this, and I know this is not legible, so I'll just create a data frame around this, call it results pd dot data frame and KNN classifier CV results. Okay, so if I print out the results, this is all the results. So for all the 10 folds, you have data here till from split 0 to split 9, and then you have the mean test score, you have the standard test score, and you could also do one thing, which is to print this, not rather print this, but to see it in a graph. So to see that, I will be importing matplotlib dot pyplot as plt and plt dot plot. I will plot my, in the results data frame, I would plot my mean test score. So here you see that till about 29, this was giving you the best parameter value, which is for n neighbors, and this is dropped when it goes to, as the n neighbors increases, the score is going down. So next up is this the last part which is left. We'll be testing it on the test database, which is KNN classifier dot fit. We'll be fitting it on now the test database, and again it will take some time. depending on the values that you've chosen for the array value for n neighbors. I've chosen it to be 100. And also the cross validation, the number of folds in the cross validation to be precise, and printing the best value that I have for KNN classifier best score. I have this, and I would also want to print the best params, which is a parameter 23. So as you can see, this is 23 and that was 29 almost. So we can go ahead with if you want, we could copy paste this to store the results here and do the same thing as we did here and plot the results, and you would see again the same thing. So here 23 is the maximum value. You could go for 23 or you could go for 29. I would go for 29. So the last thing here on the classifier is then you would predict your results for if you have a database, you could do it. So if you do it for test, you could call it y predict print maybe, and you would get the values for and these are the values whether a person has churned or not based on the data that was there in Express.
Having questions? Don't worry. Just comment them down and I'll be more than happy to help you. And as always, if you've liked this video, make sure to hit that subscribe button, share this video with your fellow marketers, and visit my website at ankitbagga.com for more such growth hacks. Thank you for watching.